Okay, so here's a problem that says given that the average speed of an O2 molecule is 1700 kilometers per hour at 0 degrees Celsius, what would you expect the average speed of a CO2 molecule be at the same temperature? And so since it's at the same temperature, we can take this formula for the root mean squared velocity, which is square root of 3 RT over molar mass, and we can combine that with so we can get that formula for the velocity of the oxygen and that same formula for the velocity of the CO2 molecule, combine them into a ratio, and what we get is that the velocity of A divided by the velocity of B equals the molar square root of the molar mass of B divided by the square root of the molar mass of A. And this works because it's at constant temperature. So this gives us a formula to use with the information that we have in the problem. We've got the velocity of A, in other words, for O2 molecules. And so our job really at this point is to calculate some molar masses. And so we know that the molar mass of O2 is 32 grams per mole. And for CO2, it's 44.01 grams per mole. So the velocity of O2 was given as 1700 kilometers an hour. And now we want to figure out the velocity of CO2. And so that equals the square root of 44.01 grams per mole divided by the square root of 32.00 grams per mole. Now, the square root of grams per mole is not a unit that makes any sense, but since it's in a ratio, they're going to cancel anyway. And you'll see that ultimately we'll just be left with kilometers per hour. So let's start doing some math. So the square root of 44 divided by the square root of 32 is 1.173. And so now multiplying both sides by the velocity of CO2, the equation looks like this. And so now I'm beginning to isolate the velocity of CO2. And so I need to divide both sides by 1.173. And I get that the velocity of CO2 is 1,449 kilometers per hour, or 1,400 kilometers per hour, depending on what those sig figs look like. Okay, and that's it.